When we look out at other planetary bodies in the solar system, we almost always see large depressions called craters, and these are formed by high-velocity impacts. In fact, the solar system can be viewed as a kind of cosmic shooting gallery, and the longer planetary surfaces are exposed to that shooting gallery, the more craters they'll, over time, accumulate. It wasn't until the 1960s, largely through the influential work of Gene Shoemaker, that geologists became convinced that impact craters are present on Earth, and the very first one to be confirmed is located in the United States, in northern Arizona. This big bowl-shaped depression behind me is the Barringer Meteorite Crater, also called Meteor Crater, and it's located in northern Arizona. This was a crater formed by an impact of a meteorite or small asteroid about 50,000 years ago. It's been estimated that this impactor was traveling perhaps 12 kilometers per second, was 50 meters across, and probably weighed something on the order of 300,000 tons. The crater produced by this impact is over a kilometer across and nearly 200 meters deep. One of the real characteristic things of meteorite impact craters where an impactor strikes horizontal sedimentary layers is that the sedimentary beds end up tilted outward and away from the impact. Like these sandstones, this is Moenkopi sandstone, and it now tilts outward, dips away from the crater. This is because the meteorite can penetrate the ground and acts like a giant bomb, and the beds will actually be up-arched, tilted upward, and sometimes even flopped over upside down, close to the crater. This outcrop is a good example of these overturned or upside-down sedimentary beds. The two prominent units here are the Kaibab limestone and the overlying and younger Moenkopi formation. It might seem strange that such massive layers of rock wind up inverted as a result of an impact. But when you consider the size of the crater, these rock layers are only about as thick as is an apple peel compared to an apple, making it a little easier to comprehend how such layers can wind up completely upside down. You'll learn in the expedition's video on bedding about the law of superposition, which says that in areas not disturbed by deformation, the younger sedimentary beds are on top. Places like Barringer Crater are definitely areas where that not disturbed by deformation clause is important, and the interpretation is not as simple as usual. Much of the debris thrown out during the impact has been eroded away now, but close to the crater a lot of large pieces still remain, right where they landed some 50,000 years ago. I'm standing just outside the rim of the crater, and you can see all the debris out here. This house-sized block of limestone is just some of the material that was excavated at impact, thrown up into the air, and fell back, mostly relatively close to the crater. It's estimated that between 200 and 400 million tons of material, rock, bedrock, and the powdered equivalents thereof, were thrown up into the air and settled back, mostly close to the crater. Barringer Crater was the first recognized impact crater on Earth, and it's still among the youngest and best preserved, but many others have been confirmed, and some aren't even exposed at the surface. So how many are now in the club? There are about 174 at present, including one in Australia called Shoemaker Crater. On Earth, large impacts have occurred throughout geologic time, and some have been implicated in mass extinction events. In 1994, the world watched as fragments of comet Shoemaker-Levy produced titanic explosions when they struck the planet Jupiter. So it's important to realize that the solar system has never been an entirely safe place, and maybe sometime in the future a new impact crater will be added to the list, not as a result of new scientific research, but simply because we watched it happen.